All right, so I think we can start. I still see people joining. I will start introduce myself. My name is Ilaria Piccini. I am study director at QIMA Monasterium based in Münster in the northwest part of Germany. I'm working at QIMA since 7 years. Yesterday was my anniversary here. And together with the QIMA team, I have contributed to the establishment of the wound healing ex vivo model, which I'm excited to present to you today. Okay, so I presented myself, but with me today is also my colleague Julien. Good afternoon, Julien, and would you like to introduce yourself after you unmute?
Thank you, Ilaria. So I'm Julien Chilloux. I'm a study director at QIMA Bioalternatives. I've been working for QIMA for 7 years now. And I'm also responsible for the cell culture facilities here in Jancé, near Poitiers.
Okay, let's move now on to today's topic, the healing of wound. So wounds come in many shapes and forms. They can be cuts, puncture, laceration, and even burns, for example. The healing process for these wounds depends not only on the severity of the wounds, but also on the patient's overall health. Many wounds are kind of straightforward to treat and may heal on their own. However, others can be much more challenging, especially for individuals with conditions like diabetes or a weak immune system, for example. Wounds, as you may, of course, already know, pose a major challenge in healthcare. Impaired wound healing is a significant medical issue, and it results in, of course, lower quality of life for those who are affected. It is difficult to find up-to-date estimation, but reports suggest that in Europe, for example, up to 2 million people may be affected by chronic wounds, while in the US, this reaches 4 to 5 million people. Of course, this means this issue places a substantial financial burden on healthcare system, as you or we all can imagine. And of course, all indications suggest that this global market of wound care will continue to grow in the future. So regarding treatments, many treatment options are available today, but there are still many more under development aimed at further improving the wound management. These products work in various ways, of course, to support the wound healing. They can speed up the healing process. They can mostly prevent complications like infection and assist with challenging cases where the wound may not heal on its own. So what type of products are out there? There is a range of medical devices like dressed in different type of dressing, as well medication in the form of cream, gels, and also specialized dressing. Also, dermal substitutes can be highlighted, which are a bit more complex in their composition, and also growth factors can be applied to further accelerate the healing process. So our work in the area of wound healing is basically, of course, to support companies by testing the efficacy of their drugs and products using preclinical relevant model. This testing provides our clients with, of course, insight into the molecular and the cellular processes that are maybe impacted by their compounds. But equally important, we also assist clients during the preliminary phases of their research in exploring, for example, new mechanisms and processes that could potentially serve as target for future therapies. And now let's move on and discuss a bit quickly, as easy as possible, the physiology of wound healing, and then get into the heart of our method today. So the physiological process of healing of a wound occurs through 4 temporally and spatially overlapping phases: hemostasis, inflammation, proliferation and granulation, and maturation and remodeling. So first is hemostasis, which is the body's immediate response.